Okay, in 14.4, we are going to prove theorems again. We proved theorems in part 1 of the course. To prove a theorem is to show that you can derive it using our rules from no premises. So we're just going to do the same thing again. We start with no premises, and we show that we can derive the conclusion. In this case, the conclusion we're given says all things are such that they're either F or not F. It's basically everything either is an F or is not an F. How should we strategize? As usual, I like to look at the main operator or quantifier, and I see it is a universal quantifier. And the rule that allows us to get a universal quantifier is the AI rule. And so if I had F some name or not F of that name, I could use the universal introduction rule. I'll replace all A's with X. Assuming A didn't show up in a premise and isn't in an open assumption. And since we have no premises, we're guaranteed that's true. So what I want then is this, so that I can use AI on it and get that. What rule should I use to get this? Well, I know that because I have no premises, I have to start by opening a subproof, and my choices, just like before, are CP or IP. When do you use which? You use CP when you want a conditional, and for anything else, use IP. Unless you have some other way to get that thing. But since we have no premises, we have no other way to get that thing. What we want is not a conditional, it's anything else, so let's do an IP. What should be the assumption for indirect proof? It should be the negation of whatever we want. Since we want this, it needs to be the negation of this whole thing. That means we have to put the negation outside of parentheses, so it applies to the whole thing and not just to A as an F. And our practice has been to call this assumption for indirect proof. The proof checker way doesn't require that we write anything down to justify or just signal that we've made an assumption. The fact that it's indented does that. What do we do next? Where are we trying to go? Well, we know that to end an indirect proof, we need to end with a contradiction. Here's another thing that is slightly different in the proof checker from the way it was done, at least in the Canvas exercises. I had us end with one sentence that was an explicit contradiction, something, conjunction, dot, or and signed, something, the negation of that thing. Whereas in the book, it has you list the two contradictory things one after another. So instead of something like P and not P, instead you would end with P, not P, one right after another. If those are the last two lines of your indirect proof subproof, then you close it up and you get to put on the next line the negation of the thing you assumed. And that's how the proof checker wants it done too. Okay, so we know we're trying to derive contradictory statements. How do we start from here? Because there's not a lot you can do with the negation of a disjunction. Now, we did prove De Morgan's laws previously as theorems, so we know that, I'm just going to use it in a simpler with just P's and Q's, even though they should be Greek letters, just so it's a little more familiar looking. We do know that this is logically equivalent to this. And so the book said we could basically do this and write that it's a theorem. But I don't believe that the proof checker allows us to use theorems. And I am not confident. I don't see theorems listed anywhere in the proof rules. I'm not sure. If you find out otherwise, definitely let me know. But we're not allowed to use theorems, which is unfortunate because then you have to prove them over and over again. Or do the proof the long way over and over again. This one isn't terribly long, but it's a little long, much longer than if we could just do this, because look, that is already a contradiction. And then we could just go FA, end the proof, call it a day. And if you did that, say, on an exam situation, I'd totally allow it. You can use theorems, specifically De Morgan's, because it is so important a theorem. And sure shortens a lot of proofs. But let's not do it that shortcut way. Let's not use De Morgan's law or theorem. Let's do it the long way. Okay, so I can't really do anything with my line 1, which means I'm going to need to open another subproof. What do I want? I want a contradiction. I suppose in theory it could involve a conditional, but I have no reason to think it will. And since what I want is something other than a conditional, even though I don't know exactly what it is, I'm going to do an indirect proof. But I still kind of need to know what I want to get started. And here's where it's kind of hard for me to explain strategy, because I can just see that the thing that I'm going to be able to derive a contradiction with is this, because I know that P or not P is a logical truth. I mean, that's what we're proving, right? You know it too, because I'm asking you to prove it here. That's what this says. F or not F is something that's definitely true. So I should be able to prove that, which would be contradictory with this. So I want to get F or not FA, like A is an F or A is not an F. And that'll be the thing that's contradictory with line 1. Our assumption doesn't have to be involved in our contradictory statements at the end, but it certainly can be. And I also remember that weird rule called disjunction introduction or addition that allows us to get a disjunction. So I'm going to say I want FA. If I could get FA, then I could use disjunction introduction to get FA or not FA. And that would be the negation of line 1. And so I'll just use the repeat rule to get it down here. And I don't know what they're calling DI in the proof checker. Let me take a quick look. It is called or introduction or wedge I. So DI is now called, or addition, as it was called in the book, is going to be called wedge introduction. So if I had FA, I could use wedge introduction to get this, the repeat rule, then I would have my last 2 lines would be contradictory. I could end my indirect proof. I would get the rest of the proof as already written. So I'm going to make my assumption for indirect proof the negation of what I want, which is not FA. And I know that I have to end this with 2 contradictory statements. And it's basically going to be the same strategy from not FA, which is just an assumption, which now using proof checker rules, I don't have to justify. I can use the addition rule, but I'm going to introduce it so it is in the same order as line 1. So that way it's clear it's contradictory, symbol by symbol. So this is going to be line 2, the addition rule, which we're now calling wedge introduction in the proof checker. Then I'm going to repeat line 1, and now lines 3 and 4 are contradictory. 1 is exactly the same as the other, plus or minus a tilde, so I get to end that subproof on line 5. I put the negation of the assumption on line 2. I cite lines 2 through 4. And And what are we calling this in the proof checker? Is it still called indirect proof? No, it is called reductio ad absurdum, or RAA. And then on line 6, I already said I would do or introduction. Now we know that was on line 5. On line 7, we just do one repeat. Now line 6 and 7 are contradictory, so we get to end the subproof. On line 8, I put the negation of my assumption. I cite lines 1 through 7, reductio ad absurdum. And then on line 9, I get to use this. And because this name is not in a premise and it is not in an open subproof, it's in a bunch of closed subproofs, which is fine. But on line 8, there are no open subproofs that involve the name A. So we get to use AI on line 9. You can enter this into the proof checker exactly like this. Everything, the way I've written it, including where I opened a subproof and how I named the rules, will check out in the proof checker if you want to run it through yourself. Here's one that's a little easier. See if you can do this one on your own, and then we'll do it together. All right, how do we get started? Well, main quantifier is universal, and so I'm thinking to myself, I'm probably at the last step going to use AI. And what would I need in order to do that? I would need to have this with some name. And in order to use AI, that name would have to not show up in any premises or assumptions that are still open in an open subproof. Okay, so what I want is a conditional, and then once I have that conditional, I'll use AI to get a quantified claim. When you want a conditional, do a CP. So line 1, assumption, let's make it the antecedent of a conditional we want. In the proof checker, we don't have to justify it. And we want the last line of our proof to also be PA, which is weird. And I'm not sure if the proof checker would allow you just to cite line 1. And what are we calling conditional proof? Our conditional derivation, we're calling the rule arrow introduction, because technically at line 1, the first and the last line of the subproof are such that the first line is the antecedent and the last line is the consequent. But if it doesn't allow this, then we can just, on a new line, use repeat. 1, repeat, because if line 1 is true, then it's true again on line 2. Close subproof. Write down conditional whose antecedent is the assumption and whose consequent is the last line of the subproof. Cite lines of subproof. And that's what we're calling it in the proof checker. And then our last step is to add the quantifier and change all A's to X's. And there is our complete proof. If you enter that into the proof checker, where you open up a subproof just like this and use these rule names, this will check out.